Welcome everyone. Today we're covering one of the most critical process parameters in viscose rayon spinning, the dope viscosity, measured by ball time, and how it directly controls jet strength and spinning stability. This presentation focuses on the importance of viscose viscosity in viscose rayon spinning. The headline number to remember throughout this talk is the ideal range, 38 to 45 seconds. Keep that in mind as we go through what happens above and below this window, and what factors help us stay in it. This slide shows the viscosity spectrum as measured by ball time in seconds. The green zone 38 to 45 seconds is our sweet spot. Below 38 seconds the dope is too thin, above 48 seconds it is too thick. Between 45 and 48 we are in a caution zone where problems start creeping in. Operators should aim to keep the spin dope squarely in that green band at all times. This is the single biggest lever for jet strength and spinning stability. When viscosity drops below 38 seconds, the spin dope is too thin. As the jet exits the spinneret into the acid bath, it cannot form a strong outer skin quickly enough. The result is a weak jet that is prone to breaking, fusing together with neighboring filaments, and producing fiber that will not drop properly. On the shop floor, this shows up as frequent filament breaks, and down stoppages, and yarn that lacks strength. If you see these symptoms together, check your viscosity first. It is often the root cause. On the other end of the scale, above about 48 seconds ball time, the dope becomes too viscous. This causes physical problems at the spinneret itself. Holes can partially clog or choke. Flow through different holes becomes uneven, and gel particles may form within the dope. The jet becomes unstable as it exits, and counterintuitively, jet strength actually decreases beyond this point even though the dope is thicker, so more viscosity is not always better. There is a clear optimum. Let us compare the two directions directly. As we increase viscosity from a low starting point, jet strength climbs. This is good, up to a point. But once we pass roughly 45 to 48 seconds, the choking and gel formation problems start to dominate, and jet strength actually falls again. On the flip side, decreasing viscosity has a more straightforward negative effect. The jet just becomes progressively weaker, softer, and less able to survive the spin bath, directly translating into lower yarn tenacity. Finally, here are the levers that, together, keep jet strength where it needs to be. Salt index between 8 and 13, carbon disulfide uptake of 30 to 34%, and good pulp degree of polymerization all feed into a dope that behaves correctly. Steeping at 17 to 19% caustic, control ripening, and clean spinnerets ensure the dope reaches the spinneret in good condition and extrudes cleanly. The acid bath sulfuric acid at 8 to 12%, zinc sulfate at 1 to 2%, sodium sulfate at 16 to 22%, and a temperature of 45 to 55 degrees Celsius is what coagulates and regenerates the cellulose into a strong filament. Get all of these right together, and you will consistently produce a strong, stable jet and good quality yarn. Thank you.